All right, here is one of the reasons that we had that prerequisite worksheet, because E and logarithms and all that kind of stuff was going to find its way back in. And I think we know that e to the x, yeah, it's its own derivative, and if it's its own derivative, that means it's also its own antiderivative. And so I think we know this first one here, that the antiderivative of e to the x is just e to the x. But what that also means, and this should probably be du right there, slight typo, but if it's e to the u du, the antiderivative is going to be e to the u. Okay. Now, u could be something much more complicated, and that's where substitution is going to come in. So our goal here, whenever you have e, is to get it to say e to the u, if at all possible, because we know how to take that antiderivative. It's just e to the u. It is its own antiderivative. And so we take a look at this first one. It does not say e to the u. It doesn't just say e to the x either. It says e to the 3x plus 1. And so our job is to try and get it to say e to the u. So u is obviously going to be then 3x plus 1. Now, there's no guarantee that substitution is going to work here, but you've got to try. And then du is 3. Again, the dx is really underneath, remember, and we multiply it up. And unfortunately, we don't have the 3. And so we divide it out. So now the 3x plus 1 is substituted for, so is the dx. So will this actually say e to the u when I rewrite it? Is really the goal here. It will. Very close, except with one small difference, that dx is actually going to be 1/3 du. And then it would just say e to the u. Okay, really, that's your goal. And that's what we've accomplished. And the antiderivative then is quite simple. 1/3 e to the u plus a constant. And then all you have to do is put u back in. Notice that this is indefinite, and so there's not just switching to the values and things like that we were doing the other day, because there's no numbers there, and so you just put the 3x plus 1 back in. Done? Seems too easy? Well, that's because e to the u is its own antiderivative and derivative, and so they can get more complicated, but that's why these do sometimes seem too easy, because it does work out so nice. Are you always going to be able to get e to the u, though? No, you won't always be able to get that, and so that's why we're going to have to find another way of doing those. Okay, I know these don't, yeah, they do seem simple, and really I'm glad that you feel that way, but, oh, what about this one? Now, if this was a derivative, you'd be saying product rule. But it's not derivative, it's antiderivative. And we haven't really done any multiplying. And so we have to get it to say e to the u, and hopefully we can. Well, we got to try. Then u has to be, there's really not much of a choice here, it has to be negative x squared, because I need it to say e to the u. Okay? And so then du is negative 2x. Again, the dx would then get multiplied up. Well, I don't have the negative 2. I've got the x part, which we need. I don't have the negative 2, so we're going to get rid of that. But right, either you can take this 5 and throw it out front before we even start, or you can say, I need a 5, and you just put it there. Okay, and you put it here too, but you get the idea. All right, and so basically when you go to rewrite, will it say e to the u du if I go and rewrite this on the inside? It will. But what's going to be on the outside is a negative 5/2 on the outside. And that's going to be negative 5/2 whether you put the 5 out first or whether you do it inside the problem. It doesn't matter. It's still going to be negative 5/2 out front. Then it will actually say e to the u du. We got it to say what we needed it to say. And once again, that antiderivative, once you get that far, really not that bad. And this is indefinite, so don't forget the constant. And not much more to do, just replace u, because it is indefinite. There's no need to switch any values. So replace it with the negative x squared that we know it to be. Yeah, of course, these do seem a little bit easier, but let's face it, not every function I'm going to give you is going to be done by substitution. Okay, there is another way we're going to learn maybe at the end of this week that'll help us if it doesn't quite work out right for substitution. Okay, but I would strongly recommend, if it is a harder one, always look for substitution first. This one's definite, which means we are going to put some values in when we get done. So we can switch the values if you want. It is completely up to you. But we do need it to say e to the u. Huh. Well, how are we going to do that? Well, let's try that. It's just, obviously, what do we have to do? If it's got to say e to the u has really little choice. It has to be 1 over x. I would probably, yeah, or look at it as x to the negative 1, right? If substitution is going to work, that's what it has to be. You're limited. Now again, this is derivative. Okay, derivative of x to the negative 1 is negative 1 x to the negative 2 dx. Do we have a x to the negative 2 in the problem? Well, technically we do, because there's an x squared on the bottom. And so what some people do is they prefer to rewrite this one as negative 1 over x squared so they can see that the x squared is actually on the bottom like it's supposed to. There is one thing I don't have, though, is the negative. We could pretend that there's a 1 right there. That's fine, but we don't have the negative. And so basically just show the negative out there and then makes that a positive. So if I rewrite it, do we get e to the u is the question. And we actually do. There's a little bit extra out front. There's a negative out front. This basically x squared on the bottom dx becomes negative du, and so there's your du, and we're left with e to the u. Now here's where you got to make that choice. You can either go all the way through the antiderivative, put the x's back in, and then use 1 and 2. Or you can change those values to what they would be with respect to u. It's a choice you want to make, and by what I saw walking around, most of you switched it to what they would be as far as u is concerned. And it's up to you. That's how I do it. You like that? So you put 1 in. And u is 1. Put 2 in. 1/2. Okay. So it's the same problem, slightly written different. Then negative e to the u. Notice no constant this time because it's definite. So put what happens? So it's negative e to the 1/2. Remember, that's putting in the top number minus whatever you get putting in the bottom number, which is negative e to the 1st. So the only thing I'd probably do to clean that up is just write it negative e to the 1/2 plus e. Could you factor stuff out? Yeah, but that's... And realize, some of you are saying, but I thought we were supposed to get a number when we did definite. Well, that is a number. Remember, e is 2.718. It stands for something. And you could go get that decimal if you wanted to on your calculator, but I'm fine with this answer as well, because that's exact. So it is a number. It's about 1.07 apparently, if you go get that decimal. Okay. Any questions on e? Yeah, like I said, it's really not too bad because you only have one option, and that's you've got to get e to the u.